Welcome to solverfy.
In this problem, we are asked to draw graphs of three different photographs of position versus time, velocity versus time, and acceleration versus time. And we're told that the time interval between snapshots is constant. From the first set of pictures, we can tell that the position drops like as a square or as a parabola. The position versus time, we can take just by plotting some other points and looking at the separation. We can see that it is a square in time or a parabola because the time interval is constant and the velocity, the average velocity, is equal to delta x over delta t. The velocity is really linear with the time, with the space, with the separation, with delta x. Delta t is constant, so the velocity decreases with the time, and the acceleration, because of that, has to be constant but negative, some constant value, minus a0, let's say. For the next set of graphs, for question B, again, the position increases linearly with time for each of those different time intervals, t1, t2, t3, t4, and t5. The position increases linearly with time the velocity is constant because the separation is constant and delta t is constant. Remember that. So the velocity is constant, or a horizontal line, and the acceleration is 0. The object is not being accelerated. The acceleration is pretty much right there. And then for the last graph is the opposite of A, of the first graph. The last set of graphs for C, the position increases as the square in time. So we have little separation, and then it starts growing like a polynomial, and it takes like that. So it's t squared there, and t squared here too, proportional to t squared. And the first, the velocity here increases linearly. With the separation, remember the timestamp, the velocity is equal to the initial velocity plus ax t with constant acceleration, and the acceleration is just going to be a positive value with time, some positive a0 greater than 0. So those are the graphs for each of the photographs.